Hi, I Aziz welcome you to CoedMaster, and in this video I am going to talk about this problem. So let's get started. Alright, let's see this very interesting problem. If you search this problem on internet, you will find this problem all over the place. And the name of this problem is best time to buy and sell stock to make maximum profit. If you search on internet, you will find multiple variation of this problem. And there are multiple ways to solve this problem. The number one approach is to solve this problem with basic approach, and that approach uses recursion to solve this problem. And the other two approaches uses iterative solution to solve this problem. So specifically on this video, we are going to talk about the first approach to solve this problem. And later in upcoming videos, we are going to see other two solutions to solve this problem. So now let's talk about this problem. So in this problem, we are given an array of prices of stocks on a particular day. So here we have array, and in this array 7, 1, 5, 3, 6, 4 are the prices of stocks for all the 6 days. So as we know that array is based on 0 index, so we can say that on day 0 the price of stock is $7. On day 1, the price of stock is $1. On day 2, the price of stock is $5, so on and so forth. Now the question is, what we have to do in this problem? So simply we have to do trading. Yes, you heard it right. We have to do trading here. And we have to do trading in such a way that we can make maximum profit. Let me show you how. So these are the days, right? So we have to buy stock and then sell the stock, and this is how we make profit, correct? So here if I buy stock on day 1, then I can sell it on day 4, and if I sell it on day 4, I will make profit of 6 minus 1, that is equal to $5, correct? But this may not be the best day to make profit. If I buy stock on day 1 and sell it on day 2, I make profit of $4. And then if I again buy stock on day 3 and sell it on day 4, I make profit of $3 because 6 minus 3 is 3. So in total, I am making profit of 4 plus 3, that is 7. Okay, so this is how we have to do trading in such a way that we can maximize the profit. Okay, so far so clear. Now, to solve this problem, we have to take care of two things. First one, we are allowed to make multiple transactions. It means we can buy and sell one share of stock multiple times. The thing we just saw, that we are buying stock on day 1 and selling it on day 2, and then again we are buying stock on day 3 and selling it on day 4. So this is how we are allowed to make multiple transactions. And second thing is, we are not allowed to engage in multiple transactions simultaneously. It means that once we buy a stock, then we cannot buy another stock. To buy another stock, we have to first sell our stock that we are holding, then we can buy another stock, then we can buy other stock on other day. So these two things we should take care of while solving this problem. So this is all about this problem. I hope you understand this problem really well. But I know this problem is a little bit tricky to understand and little bit difficult to solve. But still, I would say that if you understand this problem well, then you can pause this video now and think about an algorithm to solve this problem. And try to solve it by yourself first, before moving to the solution. Okay, so I hope you would have spent good time thinking about the solution of this problem. So let's see the brute force approach first to solve this problem. So here we have array of prices of stocks. On day 0 the price is 7, on day 1 price is 1, on day 2 price is 5, so on and so forth. So let's see the best days to maximize our profit. So if I do only one transaction, it means if I buy stock on day 1 and sell it on day 4, I am making a profit of 6 minus 5, that is $5. Okay, but we are allowed to make multiple transactions. So why not to make multiple transactions, right? So if I do multiple transactions, then there are these two possibilities here. If I buy on day 1 and sell it on day 2, I make profit of $4. And if I buy on day 3 and sell it on day 6, I make profit of $3. And if I add both the profit, the total profit comes out to be 7, and this is the maximum profit we can make as per this given prices. So if you want to buy stocks other than these 2 days, you will never going to make profit. Let's see you buy stocks on day 0 and the rate and the price of the stock is $7, and if you go in future to sell this stock, you see that the stock prices are much lower than 7. So you cannot sell your stock. If you sell it, you are going to make loss, right? And similarly, if you buy it on 2nd day or 4th day, you will make profit much less than $7. Okay, so this is the only 2 possible ways you can maximize your profit. Now the question is how to solve this problem, how to approach this problem, because so till now we are not getting any intuition to solve this problem. So what can we do to solve this problem? So we can do one thing, and that is we are going to consider all the possible combination of pair of days that gives us maximum profit, right? We consider all the pairs, and after finding all the pairs that give maximum profit, we sum it up to get the maximum profit. Let me show you how. So what we do, we start from day 0 and we try to find pair with day 0 in the future, because if we buy on day 0 and sell it on day 0, we are not going to make any profit. So if you want to make profit, we have to buy on day 0 and we can sell it on any day in the future, meaning you can sell it, we can sell it on day 1, day 2, day 3, day 4 and day 5. So using this approach, we are going to find all the possible pairs that gives us maximum profit. So we start with day 0. Let's say we want to buy stock on day 0, find pair with day 0, and here are 5 pairs. So we can buy stock on day 0 and sell it on day 1, sell it on day 2, 3, 4, 5. But as you can see that if we buy stock on day 0 on $7, then on day 1 the price of stock is $1, then $5, then $3, then $6, then $4. So here we are not making any profit. So all the pairs with day 0 is not going to make any profit. So let's move to day 2. So let's move to next day, and next day is day 1. On this day, the price of stock is $1. Okay. Now let's find a pair with day 1. So here we have day 2, day 3, day 4 and day 5. Okay. And if we buy stock on day 1, we can sell it on day 2 and we make a profit of $4. Okay. So this time we make some profit. So this time we made some profit. Now till day 2 we are done. Now still we have day 3 and we are allowed to make multiple transactions. So why not to try more and make some money? So what we do, we are going to follow the same process for next day, and next day after 2 is day 3. Now for day 3 we are again going to find a pair so that we can buy it on day 3 and sell it on day 6 to make profit. We can buy it on day 3 and sell it on day 6, 4 and 5. If we sell it on day 6, we make profit of $3. And if we go beyond 6, then we have only 1 day. So we will never be going to buy or sell in 1 day. Okay, so that is why I kept like this. And if we buy on day 3 and sell it on day 4, we make a profit of $1 only. So which is the maximum profit? 3. So we are going to take this 3. So that is why we are going to take the maximum profit out of this. So on day 5 is the last day, that is why we will not be able to buy or sell stock. And similarly with day 4 also. If we go beyond day 4, then there is only one day, so we will not be able to buy or sell. That's why I have draw like this. Okay. So in this way, we go to day 1 and find one day to make a profit, and then again we go beyond day 2 and again we make a profit of $3. So if I submit both the profit, we get 7 as profit. So we made a profit of $7. And if I again go to find a pair with the day 1, we have 3 more pairs, day 3, day 4 and day 5. And if I buy on day 1 and sell it on day 3, we make a profit of $2. And similarly, if I sell it on day 4, we will make a profit of $5. Okay. And if we go beyond day 3, then you won't be able to find any pair that will make you good profit. That is why I have make this arrow like this. Okay. And then we are done with day 1. Now let's go to day 2. When we go to day 2, we can buy it on day 2 and sell it on day 3, day 4 and day 5. And out of these 3, we are going to get profit on day 4 for only $1. So this is the minimum profit. And we have already got the maximum profit so far, that is $7. So day 2 is also done. Now let's start with the day 3. When we buy it on day 3, we can sell it on day 4 and day 5. If we sell it on day 4, we will make profit of $3, that is also less than these 2 profits. Okay. So this is the entire process where we are finding all the possible pairs of best days where we can buy and sell stocks to make maximum profit. So this is the only case where we are making maximum profit. Buying it on day 1 and selling it on day 2, and then again buying it on day 3 and sell it on day 4, and the total profit is $7. Now if you look at this thing closely, you will find that we are doing the same thing repeatedly, right? We are doing it for day 0, then we are doing the same thing for day 1, then again we are doing the same thing for day 3, right? And so on and so forth for day 2 and day 3. So what do you think? Which technique we are going to use here? I hope you might have guessed till now that we are simply using recursion here to solve this problem. And whenever we talk about recursion, we only care about 2 things. First, what least amount of work we can do. Okay? And when will the process of recursion should stop? And we also call it base condition, right? So we are going to use recursion to solve this problem, and this approach is going to be our brute force approach. Now let's see the implementation of this recursive implementation. I know this implementation is a little bit tricky to understand, but let's try to understand this with this same example. Okay, so here we have a function calculate, and this function is taking prices as array and as the index of the day. Okay, and this is our base condition, that if our index go beyond the prices dot length, then we simply have to return 0. And then we are initializing maximum profit variable to 0, and then we are starting a loop and running this loop till less than price dot length. Okay, it means from 0 to 5. So what we did in this approach, what we did before, that we choose one day at a time and try to find all the possible pairs that can make us profit, maximum profit. Okay, and inside this loop we are again initializing L profit, means local profit, and this profit is going to be global profit. And then again we are running loop from start plus 1 till prices dot length. It means if we choose day 0, then the next loop is going to run from day 1 to find all the pairs in the future. Okay, and in this inner function we are checking if price of start is less than price of I. What does it mean? It means the future price should be greater than the previous price. Then only we can sell the stock to make some profit, right? And if we found so, then so what we do in this case, we are going to simply calculate the profit we make, and then we are going to call this function recursively for the future days, okay? And it's going to follow the same process again to find the next pair, okay? And after this step, we check if the profit we are getting from this recursive call is greater than local profit or not. If we found the profit is greater, then we set the new profit to local profit, okay? And after the inner loop, we again check if local profit is greater than maximum profit or not. If we found that local profit is greater than maximum profit, we update the maximum profit to local profit. And in the last, we return the maximum profit. And this is how this recursive function is going to work. Now let's dive into this code and see how it works. So we we call this function with s equal to 0, means the day 0, and it checks for all the day 1, day 2, day 3, day 4 and day 5, and it won't satisfy this condition that price of start is less than price of I, because here you can see that all prices are lower than 7. So it just ignore all the cases. Now in next iteration, our value of s becomes 1, and we initialize our local profit is equal to 0, and then we call the inner loop for I equal to 2. Because s is 1, then inner loop starts from start plus 1, so I equal to 2, and this time the condition satisfies, so we calculate the profit. 5 minus 1 is 4, and then we are again going to call this function recursively for I is equal to 3. And for I equal to 3, it checks for next day, that is I equal to 4. And on 4th day, we can sell our stock to make a profit of $3. Plus, we are again going to call this function recursively for I equal to 5. And you can see now that the 5 is not less than 5. So we reach the base condition and it's going to return 0 to its parent call. So B0 gets returned from this function call to this function call. Then 3 plus 0 is going to return to the parent's call, and parent's call get 4 plus 3, that is equal to 7. So we are going to set the local profit is equal to 7. And our inner loops move to next iteration where the value of I is 3. And if I calculate the profit on this day, we can make profit of $2. And similarly, when I equal to 4, we can make profit of $5, and so on and so forth. And after the loop gets completed, the inner loop gets completed, we again checking if the local profit is greater than maximum profit or not. And initially we have initialized maximum profit to 0. Okay, so now local profit is greater than maximum profit, so we set maximum profit as 7. So we set maximum profit as 7. Okay, so this is how it's going to work for s equal to 2, 3, 4 and 5. So I have not written everything here just to save time and space, because we have already see all this process here, and this is exactly the same process. Okay, let me relate this code with the above explained example. So here we have a loop, and this loop is exactly corresponds to this step, right? Because loop starts from day 0, then it go to day 2, then it goes to day 1, then it goes to day 2 and day 3 and day 4 and day 5, so on and so forth. Then this piece of code, this inner for loop, corresponds to this step, that we are picking one day at a time and we are trying to find a pair with future day. Okay, and this step corresponds to this step here, that we are calculating the profit, and then we are again calling this function recursively for the upcoming days. So far so clear. I hope you understand this code really well, and you also understand these examples. By using this example, it becomes very easy to understand this code, because this code looks a little bit tricky to understand. Now talking about the time complexity of this function. So how many times outer loop is running? So as you can see that outer loop is running from start to price.length. You can see that the outer loop is running from start till price.length, means n times. But what about inner loop? In worst case, inner loop also going to run n times only, right? So the time complexity came out to be n cross n, that is big of n square. And what about the space complexity? As we know that this is a recursive solution, and whenever we write recursive solution, we need some space on function call stack to store all the recursive calls. And here at max, we need n recursive call to be stored on function call stack. So that is why the space complexity comes out to be big of n. So I hope now you understand how to solve this problem using recursion. And in upcoming videos, we are going to look at this problem again, and we will solve this problem using iterative solution. So stay tuned. So this is it for this video. Thanks for watching and see you in the next video.